Hi, welcome to the Open Learning Campus, a webinar series that we are just starting on Watershed Moments. And as part of this webinar series, what we're going to do is go through what we can expect in this Watershed Moments series and take a deep dive into one of the elements on information, which is to find a new way of looking at spatial information in an integrated watershed context. All right. So if we start, just to quickly introduce myself, my name is Harsh, and I'm the global lead for watersheds at the World Bank. And I lead the Watersheds Global Solutions Group along with my colleagues Grant Mill from Agriculture and Peter Wallowine from Water. And they're going to be here in future versions of this webinar series as well. What is a watershed? Watershed is basically the same in many ways as a small river basin or a large river basin based on your perspective. In different parts of a watershed, you have various types of activities which are usually managed by different departments, ranging from forest departments to agriculture departments to water resources agencies and so on. And the key is to try and look at this as an interconnected system where if you, for example, have deforestation in upstream areas, that affects the live storage and reservoirs downstream, which affects the way irrigation services are delivered or environmental or community services are delivered in other parts of the watershed. So everything we touch is connected to everything else, not just from a hydrologic point of view, but from a multi-sectoral point of view. In terms of looking at these, whether they be at the level of transboundary river basin or whether they be at the level of a small watershed above a small check dam, the story remains the same, to try and see how these various activities are integrated together and to take a combined look at the environmental, social, and economic context in which they are there. So now, we often talk about the three I's, information, institutions, and investments associated with watersheds. What we are looking at is right now on the information side is what we'll be focusing on today. And future versions of this webinar series will focus both on further analysis aspects and also on institutional and in the actual investment aspects. On the information side, the aim is to usually go from basic data collection to information, knowledge, and to convert that into decision support. And that's where the challenge lies in terms of trying to see how data can be converted into forms that people can access and actually help make decisions based on this. Today, we live in a world where we have a range of different tools that we have to measure our environment. For example, we have excellent ways of looking at, let's say, measuring precipitation, rainfall, snow, to look at new weather radar type systems, which are getting increasingly low cost, and to also look at ways of measuring and monitoring our water resources and land resources using a range of different technologies that are out there, including on water quality or forests. So today, in fact, if a tree falls in a forest, there are technologies to actually help see if you can hear that tree falling. So there's a lot of these different tools which we call bottom-up monitoring tools. In addition, the power is today that we can link it with top-down tools as well, where we are looking at new forms of analysis based on using remote sensing, whether they be from satellites in space or whether they be in the terms of new UAVs and drones that can fly in between, but to try and use concepts of remote sensing to look at how these types of data can be integrated. These tools are now giving us ways of accessing information on snow cover, on glaciers, soil moisture, flooding, temperature, and a whole range of other aspects which are critical for looking at watersheds in an integrated fashion. And many of these are becoming close to real time as well, which then gives us a whole new opportunity to monitor these tools. What we can do is now to see how we can integrate these systems, combining the bottom up with the top down and analyzing it with the different types of tools that are accessible, and to make sure that that information and those products can get out to actual users, whether it be in the form of, say, using cell phones or tablets, or whether you're looking at accessing them on computers or in operational control rooms of various types, to find new ways to disseminate this information and allow people to undertake even complex analysis from very simple devices. And this kind of work would require the modernization of institutions, which will be the subject of a future webinar, where we are looking at modernizing the way in which people can interact with this kind of information and help make decisions. How you go from collation of data to analysis of the data to use of the data in a systematic manner, using new types of approaches which can build on this kind of information. So when we talk about data, there's a lot of different data sets that many agencies around the world are collecting. These could be, say, a lot of the knowledge providers such as NASA and the European Space Agency, or a lot of the UN agencies such as FAO, and also other agencies like EME and other agencies like the Bank and other UN agencies, and a whole range of thematically specialized agencies, in addition to a lot of the regional organizations and national organizations that also spend a lot of resources to collect information. Unfortunately, a lot of this information tends to be in a million different websites around the world, and it becomes difficult to keep track of what information is where and to try and visualize these kinds of information synoptically. So what we've done is to try and see if we can create a tool, and this is our deep dive for today, where we're looking at a tool called Spatial Agent that we've developed at the World Bank to help visualize a lot of these types of data in an integrated spatial platform. And this also brings to light the importance of using these kinds of spatial tools that we have. We have an update coming up both on the iOS and on the Android versions soon, and these should allow you to do a lot more than what's there in the current versions. So keep your eyes tuned for this. Hopefully, this will be out in the next 2-3 weeks. And what this will do, especially, for example, in the iOS version, you also can get access to different language versions as well. So in not only in English, but Spanish, French, Russian, Chinese, Arabic, and Bahasa Indonesia to begin with. And also with a range of different features, including cloud computing. So let's take a look at the spatial agent and try to see the kinds of information that you can get quick access to. And there's a range of different features, as you'll see in a second.
Welcome to the Spatial Agent application. This is a demo of how the Spatial Agent application works. If you download the iOS or Android version, you should see an icon for Spatial Agent, something like this. If you click on the icon, you'll have an application open that shows a blank map. And on this map, you can layer different types of information that are already there in the public domain. It's important to realize that there are no data sets actually in Spatial Agent. What it does is draws upon data services from institutions around the world, including real-time information from places like NASA, all the way to country-level information provided by places like the World Bank and the UN and so on. If you go to the bottom right, and see that list that's there, you'll see a list of layers that you can load on, which could be at the level of a country. So for example, if we pick country at the bottom, you will see a list of what are called the World Development Indicators from the World Bank. And you can also pick the alphabet on the right to find it easier to go to particular types of indicators. For example, if you pick G and pick GDP per capita, you can go in and showcase what the GDP of the world looks like currently in terms of the one number per country that's collected. But what you can do is also click on a country where, for example, if you zoom in by pinching the screen and pick on, let's say, China, you'll see the rapid growth that China has had from a GDP of, let's say, 190 in 1980 all the way to about almost $8,000 per capita in 2015. You can also compare with other countries. For example, if you click on Madagascar, you'll see that the GDP per capita in 1980 was almost 3 times that of China, but unfortunately it's remained pretty much the same even after a few decades because of civil unrest and other reasons. If you wanted to look at other country level indicators, you could go in and peruse the whole list that's there, and it has a lot of different details, but these are only one number per country. If you pick the subnational tab, that's the second tab at the bottom, you'll see that there's a lot of other data sets that show up, which are actually really interesting in terms of showing a lot of the data at subnational levels. So if we look at, let's say, we pick P, or you can even type population, for example, on the search bar up here, and you can look at population data, and you can see the distribution of the types of population data sets that are there. So for example, if we look at population density information, you could see a lot of this type of information from CSIN in Columbia University. For each of these data sets, you'll see the source at the bottom left, like CSIN in this case, with a little I next to it. And if you click on the I, it gives you information about the metadata summary for that particular data sets in terms of when this was created and where you can get links to the actual online data, as well as links to the metadata associated with this. We are in the process of updating this to more recent data sets as well as a legend for the data set. And what you can then do is to look at where population density distribution is around the world, and you could also replace that with other estimations of population density. So for example, you could go and pick a more popular, finer resolution data set, which is in Landscan, for example, where you would see 1 kilometer by 1 kilometer estimates of population around the world. And you could also if you see on the bottom right, there's a little scroller where you can change the transparency so that you can see what's below, in this case, a satellite image. And if you look at the third icon from the left at the bottom, you could also replace that with another map. So for example, you could have replace the satellite image with a street map and put the same data set on top of that. And as you zoom in, you'll see that the data at the top as well as at the bottom gets to be of a higher resolution, and you can see more. You can also put boundaries on top of these data sets. So if you pick the second icon from the bottom, the one that looks like a globe, you can put boundaries of countries on top of this data, such as you can pick any of the countries of the world, or you can pick regions, which will show you entire regions like South Asia and so on, and all from a hydrologic viewpoint, as well as river basins, where you can pick any river basin. So let's say we look at the Nile River Basin. So you would see the same data, but with now a boundary which masks out the rest of the world, and you can see the Nile River Basin information in terms of where people live in the Nile Basin. And you can see in particular, let's say in the Nile Delta, where people live in Egypt, on the Nile, mainly on the delta and along the Nile. And you can also find this in the future by going to the top right and clicking on bookmarks, and be able to bookmark this site so that you can come to this later. And you can also look at trying to get this data in a way that you can use it easier in publications. For example, by picking the second icon on the top right, where you can send this information either to social media, or if we pick the first example, you can send it by email, and you can see that this image with the legend would be in an email which you can send to yourself, and you can use it in any report as well. You also have the ability to try and access a range of data sets that different organizations have put together. For example, if we look at, let's say, climate stations around the world, so all the 20,000 or so climate stations that report to the World Meteorological Organization here, and you can get a sense of any region. So if you wanted to look in Africa, or you want to look in, let's say, South Asia, and be able to look at all the different stations that report. For example, if you look at the one in Colombo in Sri Lanka, you can click on a station and be able to get the data that's associated with it. So for example, you could say you wanted to look at the average temperature and precipitation, and by putting your finger over the bars, it will also give you the actual data information. And if you were interested in not only looking at the averages of, in this case, this multimodal distribution for precipitation, or the temperature, pretty balmy temperatures that are there in Colombo all through the year, you can also go to the all years link at the bottom and see the entire time series of record. So you could see, for example, for the last over a century, what kinds of monthly precipitation values we've seen, and see the huge climate variability that has already been there in the past. And you could also zoom in to any part of this to try and get more recent, or look at a particular period to try and see the information. You could also see tabs, have a look at in each of these data sets, you'll see options for other types of data that you could see. For example, here on the top left, you can change from precipitation to temperature. And in this particular case, you can also see the rise in temperature in recent decades as well, which you can also zoom into to be able to have a closer look at this type of data. So you can look at trying to use the evidence base that exists and be able to make your own decisions about different aspects and different development challenges. You can also access a lot of data. Again, if we go back to our list on subnational, you can access data sets that are in real time. So for example, if we look at a recent NASA data set which replaced the TRIM data set that they had earlier, which estimates precipitation, we can look at this new GPM precipitation data, and again you can put different backgrounds to this. So for example, if you wanted to look at putting a satellite map and seeing this data on top, what this is showing is how much rainfall has happened around the world in the last half an hour. Right? And you can change this half an hour and see see, for example, how much has been happening over the last day, or the last 3 days, or the last 7 days, and so on, and be able to access a lot of these data sets. And also, again, remember that it's easy to do transparencies and put other boundaries like river basins on top of this. You can also get access to the raw satellite data. For example, if you look at one of the major workhorses that NASA has had over the years, it's the MODIS satellite data, and you can get access to that data by looking at the land surface reflectance data in near real time, which then shows you the latest satellite coverage from any of the two MODIS satellites, Aqua or Terra, and you can see the different bands as well. So if we look at one example such as this, you could also not only see what the world looks like right now, but you could also go back in time and say, what did the world look like yesterday, or if you wanted to look at it as last year or last month and so on, be able to access a lot of these types of data sets. And the advantage with this is that it could also give you visual clues to what's happening around the world, and you can even track cyclones and hurricanes and so on. But if you actually want to look at historical records on hurricanes, you could also go and look directly at things like cyclone tracks, for example, which give you a good overview of what kinds of hurricanes and cyclones there have been around the world by looking at studies that have been done for long periods of time. And you could see not only these hurricane tracks and also colored by category. So you can see the category 5 hurricanes would be in dark green. You could also see where they're hit. So for example, I often thought that hurricanes hit only the eastern side of Madagascar. But if you go closer, and sometimes it takes a little while for the data to load because it's drawing from a live service, you can see that hurricanes hit on all sides of Madagascar and not just the eastern side, just because of the nature of the activities there. And you could also go in and get access to data sets relating to the measurement of surface processes from remote sensing, such as lake levels. So there's some clever data sets that are now out there where you can say, gee, I wonder what Lake Victoria looks like in terms of lake levels, and click on Lake Victoria and see the generations of satellites that have been tracking it since about 1992 to try and get access to almost every 10 days what the lake levels look like. And you can also zoom in into any particular portion of this time frame to see what the lake levels have been up to. And you could also see other processes, these kinds of processes in other river basins. For example, if we look at the North Aral Sea, we see that there's been in recent years some recovery that's happened in terms of the North Aral Sea. But if we look at the Southern Aral Sea, for example, it's flatlining, and that's one of the big challenges that we have in many of the water and natural resource management aspects around the world. So there's a range of different data sets that exist at subnational level, not only through remote sensing, but also through ground measurement. So for example, if we look at the air quality index that's here, and we have a way of looking, thanks to the WAQI folks, we have a way of looking at official government sensors for air quality around the world, which are updated every few minutes, like every 15 minutes. And you can look at this data for any one of the pollutants which are listed here. For example, if you wanted to look at fine particulate matter, less than 2.5 microns in size, you could see this information categorized according to EPA standards. So you could say if it's green, it's pretty good, which you can see in many of the countries of the world. And you could see as the colors go into the purples and the browns, it's more hazardous to your health. So as you can see right now, if we look at how the world looks like, and not all the countries have yet started monitoring and sharing information in this way, but you can get a sense of, for example, places like the US, reasonably decent air quality, all the way to looking at, say, the 400 plus stations that China is putting out there in the public domain, and also the increasing number of stations in places like India. You could go zoom in into any one of these cities as well. So, for example, if you wanted to see one of the worst cities in the world from an air quality point of view, let's say Delhi, you can get a sense of how that varies across the city, and also be able to see which parts of the city that corresponds to as well. So a lot of these types of data sets can then be accessed to find out what the environment around you looks like, and also to benchmark yourself versus the rest of the world. You could also get information which people have already visualized for you. So for example, a lot of these visualizations we have created with the data, but there are many people who've taken the data and visualized it for you. So for example, if you look at a clever visualization called the Earth Wind Map, this is to be able to see, for example, what the winds look like at any point in time. Are there any hurricanes around the world? And you can go in and rotate the globe and be able to directly tap into this service that's being provided. And for any of these data sets, you can go in and see, for example, Antarctica is always something happening there in terms of the winds, and have a look at what the winds look like at this point in time, again updated every 15 minutes or so. But by clicking on this Earth symbol at the bottom left, you could also change the height at which the winds are looked at. So this is at surface. You could also look at the winds at the jet stream level, for example, and see what they're doing. Or you could see, go to ocean currents and see what the ocean currents look like at this point in time around the world, and be able to access a lot of this type of data at your fingertips. And that is the benefit of living in today's world, is that there are many people who are monitoring and carefully analyzing the information that's out there and helping people visualize the world in different ways. The challenge, of course, has always been that it's been in disparate websites around the world, but with a platform like this, it's easy to get access to a lot of this data at your fingertips. I'll end with the two last aspects, where one is you can look at World Bank projects around the world, where we have been financing programs relating to a range of different topics. So you could zoom in into any part of the world and have a look at where programs are being undertaken, and click on any icon to be able to see what the project is, and go to the external website relating to the project, which will give you more details about the particular project. You can also look at a new aspect which we are bringing in terms of using the Google Earth Engine platform to be able to analyze a lot of different satellite data sets, to develop a range of different indices, and be able to view this type of information for any part of the world. So, for example, if you wanted to see how the NDVI which is a vegetation index, is changing in a particular region, let's say the Nile Basin, you can look at this not only in a spatial manner, but you could also, by clicking on the top right, you look at how this is changing.
All right. I hope you liked the demo, and I'll just wrap up for a couple of minutes, but please do start typing in your questions so that I can also see if we can group them together in the response. As you can see, with an app like this, we can look at pulling together information on everything from forest fires and floods and droughts to erosion, snow, climate change scenarios from different models, groundwater information from satellites like GRACE, information on topography, on land resources and water resources, as well as from many other sectors, including on roads, rivers, cities, for example, to try and see what the future population growth in cities could be like. Information on forests, including the Hansen dataset on tree loss, for example, and also on crops, as well as a whole range of other information on trade and also the power, as you could see at the end, of using cloud computing, for example, as we saw in the Google Earth Engine demo on the NDVI, which we are hoping is just the beginning of a range of different services that now anybody can access for free. So with these kinds of tools, what we are hoping is that the work on things like watershed management would become a lot easier with a lot of this type of information at your fingertips, not only from what one may think were traditional aspects of watershed or basin management on things like erosion and water resources and so on, but also to look at a whole range of new types of tools that we can now pull together to go up that chain from data to information to knowledge to decision support, and using apps, portals, ebooks, competitions, e-learning, a whole range of different platforms that can take advantage of using these kinds of systems. So maybe now let's go in and look at some of the questions that are coming on, and we'll be taking these. So let's go to those. Okay, please do type in your questions. I see a few that we can get started with. So one from David about is there any limit to the number of data layers that could be added, and how will the data be curated? That's an excellent question. What we are looking at here is to recognize that the app itself has almost no data. It is drawing on data services from other providers. So for example, every time I click on, let's say, the GDP per capita information on a country, it goes to, let's say, data.world.At and pulls in the data. And the same thing for a range of different services that are out there as well. And in this regard, there really is no limit to the number of data layers that you can pull together, because there's no physical services that we are undertaking. And in fact, developing such apps are also a clever way to avoid a lot of this kind of serving overhead. For example, right now, it's either Google or Apple that are hosting the app itself, and other people are hosting data layers. So there really are no services that we are pulling together as part of the spatial agent, but we are pointing to services that different agencies are pulling together. So this does bring up the issue about which data is good and bad, and this issue about curation. Now, this again, we don't want to be the data cop here. So what we are doing is to try and see if we can focus on data from large agencies that have their own curation responsibilities. For example, data from NASA or UN, FAO, or EME and others, or the World Bank itself, for example, to try and see how these types of data are pulled together in a way in which these kinds of data can have their own curation within these organizations. And if they are alternative facts from different organizations, to try and see if these could also be highlighted as alternatives within such apps, where you can make up your own mind then in terms of how this data is useful. And we're planning to build a little social media interface to that, so that we can hear from all of you in terms of what kind of data sets do you think are useful, and other data sets that you think are better than others for particular regions or themes, because this is a very rapidly evolving space. For example, on population, there used to be population data from a range of different agencies at country level, now at subnational level through, let's say, CSIN and others, as well as now through Landscan or WorldPop, or even through Facebook now is expected to have even better population density data set coming up. So to try and make sure that as and when these become accessible, to be able to point to these different data sets and then to pull those together. Another question here is on whether this kind of an app could be accessible on a PC as well, or is it only for smartphones and tablets? This is a really good question, and what we are doing here is, although accessing it on a PC or a tablet, and nowadays the boundaries are becoming blurred between PCs and these, is what this was originally aimed at. We now are working with the bank ITS, the IT group at the bank, to make a web version of this as well, which can then be accessed on any service, on any kind of a computer or a laptop or a desktop. The advantage with that will be that then you could probably go a little easier from the data services that are highlighted here to trying and downloading the data wherever it's possible for additional analysis as well using GIS or other systems. But it's something which we hope we can get out in the next 2-3 months, beginning with some of the water and environment related data sets and then expanding it to other data sets. As I mentioned, now we have a range of other types of data on trade, on poverty, and other aspects that we are trying to pull together as well into these applications. So stay tuned for future versions of these data. In addition, to also let you know that in the new version, you'll have an online tutorial as well. So with this online tutorial, with the Open Learning Campus as supported, you can have access to illustrative multimedia kind of help desk of how different data layers are out there and how you can pull these together and visualize them, as well as being able to make sure that this kind of data can be then used for different purposes. This is related to the next question, which is on whether it's possible to export the outputs or, for example, to print the maps that you can find on this app. Yes, as I mentioned in the video earlier, you can export this data either as a link which you can then visualize in any social media like Twitter, Facebook, and so on. But you can also send it to yourself on email, so which will then send you the image which with the legend if it's a map, or a graph if it's a graph that you are exporting. And you can then use that either in a document or you can print it as well. In the web version, we are adding a few more types of features in this regard to be able to visualize and access a lot of these types of data sets as well. All right, a couple of other questions. One is in terms of what are the requirements in terms of internet connection for this app to work? That's a good question, because although internet connections are becoming easier and easier in all the countries that we work in today, you still have many places where, let's say, broadband internet is harder to find. But we've tested this app in, for example, remote areas in Malawi with very simple 2G or 3G connections on a cell phone, and it seems to work pretty well, because as it's been designed, it has a lot of neat features in terms of tiling and so on, so that the app itself doesn't need to do much in your device, and it's drawing on data services from different places. A little bit depends on how those data services are in terms of the speed of those data services. So if, for example, a NASA server goes down for maintenance, you will not be able to access the data at that point in time. With the ways around it as well that we are trying to get over in terms of that regard. But what you can do is, as you're visualizing data for the whole world, and as you zoom in, it will start bringing in higher and higher resolution data. So that this kind of tiling effect makes it then much easier to be able to access huge data sets and have them at your fingertips whenever you want them as well. And so that way, a lot of the internet problems that are there are becoming less and less relevant. You also, and we are trying to do this more systematically, you can cache some of the data. So if you go in and visualize a few things and you keep going back to those, you should be able to use some of those, especially some of the country level data. You should be able to use those even without an internet connection later as well. We didn't want to make the app itself too big, so we are keeping it rather small so that it still continues to access data services instead of hardwiring in the data. So that way, if the data changes from the provider, you can see the new versions of these data sets. We also have included a showcase. So in addition to the global data sets that do exist from a country point of view or a subnational point of view or a trade point of view, you have subnational data that we've highlighted, whether it be to look at an example of what a high resolution digital elevation model looks like in the case of Netherlands, in this case, where there's a service for that at 0.5 meter by 0.5 meter, or if you want to look at other types of data sets that do exist, where you're looking at the level of a city or a basin or watershed or kind of an administrative area, to be able to look at those kinds of data as well. So those are things that you can pull together. Another question is from Oscar is, if you have your own data, what's the best tool to create maps? Of course, in this particular case, just because of the fact that there are many different projections and different types of data sets that are there, we still have not made a system in which you can upload your own data in this app. We're just trying to make accessible different existing data sets, so to help visualize a lot of these types of data as you're looking at them. In terms of your own data, the best way is to actually look at the data services that you're interested in, and then use a desktop or other tool such as GIS or an online tool like GIS to be able to visualize not only these data sets but also your own data as well. And this is something which is becoming easier and easier to do, and eventually, as everything starts moving to the cloud, it'll become easier for you to look at this all together as well. So there's some other comments on the app itself, and thanks for those comments. For example, I think there's a comment which, let me scroll down and see what it is. Yeah, so the question is, can the harvested data from different organizations be cross-linked again within the app for any cross-cutting searches or queries? This is what we are trying to do now. What we are trying to do is to be able to pull together different keywords, for example, for different types of data sets, data services that we are highlighting. And as part of these keywords, what we're hoping is that when you type, right now, if you type, let's say, climate, it'll only show you data that has the word climate in the title. And what we're hoping is to also show then data related to anything that says temperature or precipitation or disasters and so on, to be able to visualize those as well. And as part of that way we can try and visualize data from different organizations. Often a lot of organizations take data that you can access through these systems and then do their own value addition. So that's something that we are trying to see if we can showcase different products related to these data sets and the derived products as well. Yeah, there's a question on tools, on data on wildlife populations, on whether those are things that we can add. And yes, that's in fact one of the things that we are doing is to try and work with the EU, JRC, and a whole range of others, WWF and others who have a lot of different types of data sets in this regard, and try to feature at least the public domain versions of these data. And also we are working with a group inside the bank on featuring information on illegal wildlife trade, for example, to try and see how a lot of these types of data sets could be visualized. In addition to data about the actual wildlife, We're also trying to see if we can feature information about the types of responses to illegal wildlife trade. For example, different projects supported by a range of different agencies, to be able to visualize and categorize them together in a synoptic way, which allows for a lot of interactivity in terms of looking at these types of data sets. So keep your eye out for that. We should be able to feature a lot more of the wildlife trade aspects as well coming up. As you can see, a lot of these data are multi-sectoral. They are not in a very traditional viewpoint, looking at only population data or only erosion data or only rainfall data and so on, but allowing people to look at those, but also keep in mind other types of data that exist on the same space. So if we are looking at, let's say, a spatial reference like a watershed or a river basin, to be able to visualize a lot of these different data sets together and be able to see how these can be pulled together. And that way, a lot of what we're hoping is that the kind of evidence base that exists now can be used to try and visualize to be used for actual decision support at different levels, whether it be for planning level decisions or for real-time operational type decisions. So that's the challenge in which we can try and see if we can pull together these kind of data sets. So just to maybe wrap up, if there's no additional questions, one of the things that we'll try to do in this series is to have these kinds of webinars where we can feature a lot of the work that's happening on different aspects of watershed management and river basin management, whether it be not only on a theoretical basis, but to be able to do a deep dive where you can have takeaways from the point of view of access to new types of information and tools that you can use for your decision support as well. And also to have examples of case studies. For example, we are starting to feature a lot of story maps as part of the Spatial Agent, but we plan to pull a lot more of these kinds of tools, not just on the data and analysis, but also on case studies that you can get access to, including on information about new ways of monitoring these watersheds, as we talked about earlier, or new types of remote sensing information that's accessible today that we couldn't even dream about a few years ago. So a lot of these kinds of things that we are hoping we can do. And as one of the questions says, is there, if you have suggestions for additional data or additional tools that you would like to see, and more important, if you have data sets or data services using Open Geospatial Consortium standards that are out there, if you can make sure that these data services are things that you think really could benefit a larger community, please do email us, and we'll be happy to feature these as well. You can see the feedback form as part of the Spatial Agent app itself. And please do let us know if we can support a lot of these types of data sets in the future. Right, okay, so thanks a lot, guys.